In 1928, two revolutionary polymers arrived on the world stage. In Philadelphia, America, Walter Diamond finalized the recipe for the modern bubblegum, a pliable, sticky polymer that would define a generation. Across the ocean, in a London lab, Alexander Fleming discovered penicillin, the molecule that would usher in a golden age of antibiotic discovery. As penicillin revolutionized medication, and amoxicillin, an antibiotic related to penicillin, was developed, we often gave it a friendly, familiar identity, a bright bubblegum flavor that made it easy for a generation of children to swallow. But we've hit a major roadblock. The effectiveness of penicillin is now fading, much like the flavor of gum, and for a surprisingly similar reason. It all comes down to stickiness. The enemies we face now are superbugs, bacteria that have evolved to be resistant to multiple antibiotics. We are losing the war because these superbugs have learned to talk to each other, to quorum sense, and that communication triggers them to build a biofilm, a slimy, sticky, impenetrable polymeric shield that physically stops every antibiotic we fire. Our old strategy was to use strong antibiotics, but that's like trying to use a bigger cannon to break a sticky fort wall. It fails because every time we use a cannon, a few bacteria that survive just get stronger. Our new strategy is nano-quenching. We stop trying to kill the bacteria and instead disrupt their teamwork. We use a quorum sensing inhibitor, a QSI, a molecule designed to jam the bacteria's communication line. This is a process we call quorum quenching. We deliver this jammer using a nanocarrier, a tiny delivery truck engineered to tunnel right through the sticky biofilm shield. The nanocarrier delivers the QSI past the stickiness, suppressing the superbugs. The bacteria, now disorganized and exposed, are easily wiped out by our old friend penicillin. This method is revolutionary because it restores the power of existing drugs and is less likely to cause antibiotic resistance than traditional methods that outright kill the bacteria. The main challenge in the current research is to ensure that the nanocarriers are perfectly stable, scalable, and non-toxic in the human body. In 1928, two polymers represented two distinct forms of human innovation. Today, we are using the advanced chemistry of polymers and nanotechnology to disarm the sticky defense of the superbug. The idea that brought us bubblegum and the power of synthetic materials it represents is the same concept that offers us the best hope to restore the age of antibiotics.